Now next topic is section formula. If suppose there are 2 points A whose coordinates are x1, y1, z1 and another point B whose coordinates are x2, y2, z2. These are points in the space. Line segment joining A and B. Now, if we want coordinates of a point dividing this line segment, suppose P is the point which divides this line segment in ratio m is to n. It divides internally. Then coordinates of P can be found. So here I am putting statement. This is for internal division. Coordinates of point P dividing line segment joining point A whose coordinates are x1, y1, z1 and point B whose coordinates are x2, y2, z2, dividing internally in ratio m is to n is, so coordinates of these points are, formula is mx2 plus nx1 upon m plus n, my2 plus ny1 upon m plus n, mz2 plus nz1 upon m plus n. Already you learned about a section formula in R square. Now this is section formula in the space in R cube. So one more coordinate. Method is similar which you did in class 10. Now if P divides externally, point P divides externally in the ratio m is to n, then if P divides externally, that means if AB is a line segment, then P is a point on this line. It can be either on this side or point can be on the left side of this line segment EB. So here in this both diagrams, P divides externally. That means P is a point on a line AB, but it is not a point of line segment. It belongs to line AB, not line segment. So point P is such that A dash B dash P or P dash A dash B. So this is the diagram for external division. So either this location or P can be on this location. Coordinates of P are, if A is x1, y1, z1, B is x2, y2, z2, then only change in this formula, replace plus by minus sign. So mx2 minus nx1 upon m minus n, my2 minus ny1 upon m minus n, mz2 minus nz1 upon m minus n. So this plus sign will be replaced by minus. Then now in this discussion, if we replace this ratio m is to n by k, if k is m upon n, then This statement can be expressed as coordinates of P dividing line segment AB in ratio K is to 1. K equal to M by N, that means K is to 1. So coordinates of P dividing AB in ratio K is to 1 is, so coordinates are Kx2 plus x1 upon K plus 1, Ky2 plus y1 upon K plus 1, Kz2 plus z1 upon K plus 1. And similarly here also we can put statement by this method, that if K is M by N, then coordinates of P dividing line segment AB here internally, I am correcting this statement, internally in the ratio K is to 1. Here externally in the ratio coordinates of P dividing line segment AB externally in the ratio K is to 1 are, coordinates are from this formula Kx2 minus x1 upon K minus 1, Ky2 minus y1 upon K minus 1, Kz2 minus z1 upon K minus 1. So simple form of this formula. Then one more result. If P is midpoint, if P is the midpoint of AB, then P divides in ratio, P divides line segment AB internally in ratio 1 is to 1. If P is midpoint, this will be 1 is to 1. So putting M equal to 1, N equal to 1 in this formula, coordinates of P are, coordinates of P are x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. That means midpoint. And one more result. If vertices of triangle are x1, y1, z1, this point is x2, y2, z2, this point is x3, y3, z3. These are vertices of triangle. And if G is centroid, then coordinates of centroid equal to x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, z1 plus z2 plus z3 by 3. Find the coordinates of the point which divides the line segment joining points minus 2, 3, 5 and 1, minus 4, 6 in the ratio 2 is to 3 internally, 2 is to 3 externally. First of all, we take case 1. 2 is to 3 internally. That means here This point is minus 2, 3, 5. Second point is 1, minus 4, 6. Point divides internally, means a dividing point lies inside such that it divides this line segment in ratio 2:3. So imagine 5 equal parts, 1, 2, 3, 4. Imagine 5 equal partitions of this line segment. On the left of this point there are 2 partitions and here 3 partitions. So this is the point at which it divides this line segment in ratio 2:3. Let me say this point is A, this point is B. So coordinates of point, required point, this point is P, equal to mx2 plus nx1 upon m plus n, my2 plus ny1 upon m plus n, mz2 plus nz1 upon m plus n. So it is 2 minus 6 upon 5 comma minus 6 plus 9 upon 5 comma 12 plus 15 upon 5. So coordinates are minus 3 by 5, 3 by 5, 27 by 5. So these are coordinates of this point. Now case 2. 2:3 externally. So here ratio is less than 1. If ratio is less than 1 and divides externally, then dividing point will be on the left side of line segment. So put P, then see this is the method. So this will be the location of points. First P comes, then A comes, then B comes. P is exterior point of AB. If ratio is less than 1, point dividing externally, and if ratio is less than 1, then P comes on left side. P doesn't lie on AB. So the procedure is first put point P, then put point B. Now keep A in such a way that AP is equal to 2 and PB is 3. AP is 2, PB is 3. So PB is 3, that means PB divided in 3 parts. Say this is for AP, this is for PB. Dividing point is P, so P keep common. P is common point. Dividing point always keep common. So this is for length AP, this is for length PB. So PB is 3, so show this in 3 partition. PB is 3. Now we set A in such a way that AP is 2. So if I keep A here, then AP is 2. Here now you can see that AP is 2, PB is 3. This is the way to draw diagram for external division. Coordinates of A are minus 2, 3, 5. This is 1, minus 4, 6. And this divides externally in ratio 2:3. So this point is, we can show this part by dotted line. It is an exterior point. And because externally divides externally by formula, only the difference is that this plus will be replaced by minus. So coordinates of P, coordinates of required point P R. mx2, say this is mn, so mx2, so 2 into 1 minus n into x1 upon m minus n. my2 minus n y1 upon m minus n. mz2 minus n z1 upon m minus n. Difference is that here plus sign will be replaced by minus sign. So that is, this is equal to 2 plus 6 upon 2 minus 3 is minus 1, minus 8 minus 9 upon minus 1. This is 5. 12 minus 15 upon minus 1. Sorry, here I did mistake. 2 into minus 4 is minus 8 plus 9. So 9 minus 8 is, this will be 1. Here 12 plus 15 by 5. So this is okay. 2 minus 6. 2 minus 6 is minus 4. Minus 4 by 5, 1 by 5, 27 by 5. Now it's okay. 2 minus 6 is minus 4. This is minus 6 plus 2, minus 8 plus 9, 12 plus 15. Now it's okay. Sorry. Now here 2 plus 6 is 8. 8 upon minus 1 is minus 8. Minus 8 minus 9 minus 17 upon minus 1, that is plus 17. And this is minus 3 by minus 1, that is 3. So these are coordinates of P dividing externally. Given that these 3 points are collinear, find the ratio in which Q divides PR. We suppose that Q divides PR in ratio K is to 1. Q divides PR in ratio K is to 1. Therefore, now see, we want ratio. So taking help of comparing any one component, we can find ratio. So x coordinate of point Q, it is equal to k x2 plus x1 upon k plus 1. We are comparing only x coordinate from formula. X coordinate of Q is kx2 plus x1 upon k plus 1, where this is x1 and this is x2 is 9. x1, that is x coordinate of a point P. x2 means x coordinate of a point R. x1, this is x2, and this is dividing point. X coordinate of Q, now x coordinate of Q is 5. So 5 is equal to k into x2. x2 is 9 plus x1 upon k plus 1. So therefore 5k plus 5 is 9k plus 3. So 4k is 1. 4k is 2. 5 minus 3 is 2. 9 minus 5k is 4k. 4k is 2. So k is 2 by 4, that is 1 by 2. So we can say that Q divides PR in ratio 1 is to 2. And because here we are getting positive value, So we say it divides internally. Q divides PR in the ratio 1:2 internally. If we get here -1/2, then we should write statement like this, that Q divides PR in ratio 1:2 externally. Minus sign indicates externally, 1:2 externally, and plus sign indicates 1:2 internally. Now with this question, find the ratio in which YZ plane divides line segment formed by joining points. Say here, suppose this point is -2, 4, 7 and this point is 3, -5, 8. This is line segment joining A and B. We want a ratio in which YZ plane divides this line segment. Suppose that YZ plane divides this line segment somewhere at point P. This is YZ plane. So P lies on YZ plane. So because P is a point on YZ plane, its x coordinate will be 0. So we shall use x coordinate of this dividing point. Here this point will have x coordinate 0, x0, y coordinate suppose B, z coordinate is C. So here suppose that YZ plane divides line segment AB at point P. So P lies on YZ plane, therefore P dividing point lies on YZ plane. So x coordinate of point P, it is equal to 0. X coordinate of this point will be 0, and we shall take help of x coordinate of dividing point. So x coordinate of P equal to, now we suppose that YZ plane divides AB at point P. Because we are asked a ratio, we suppose in ratio K. So let me insert these words, that YZ plane divides AB at point P in ratio K:1, and here P lies on YZ plane, so its x coordinate equal to 0, and now we are using this x coordinate. So x coordinate of a P is equal to kx2 plus x1 upon k plus 1, where x1 is -2 and x2 is 3. This is x1, this is x2. So therefore 0 is equal to kx2, so k into 3, x1 is -2 upon k plus 1. So therefore 3k minus 2 is 0. So k is 2/3. Therefore YZ plane divides line segment AB in ratio 2:3. Using section formula, show that these points are collinear. Say points are collinear A, B, C are collinear. So A dash B dash C, or it can be B dash A dash C, or it can be A dash C dash B. These are the possibilities if A, B, C are collinear. And if any 3 points are collinear, then we can speak 3 statements. We can take A as dividing point. Here A divides BC in some ratio externally. If we speak for B, then what we can say? B divides AC internally, or we can say C divides AB externally. That means if any 3 points are collinear, each point can be taken as dividing point, and in which ratio it divides, that ratio can be found. So here in this question we suppose that we are considering these as dividing point. Suppose that C, whose coordinates are 0, 1 by 3, 2, it divides line segment joining A 2 minus 3 4 and B minus 1 to 1 in ratio K is to 1. If these points are collinear, then C must divide line segment joining AB. In this question I am taking C as a dividing point because here this number is in fractional form. So we shall keep that number on left side for convenience in calculation, because they are not integer, we are taking this number dividing point. So therefore coordinates of dividing point equal to, this is x1 y1 z1, this is x2 y2 z2. So by formula kx2 plus x1 upon k plus 1 comma ky2 plus y1 upon k plus 1 comma kz2 plus z1 upon k plus 1, kx2 plus x1 upon k plus 1, ky2 plus y1 upon k plus 1, kz2 plus z1 upon k plus 1. So therefore now comparing values, this is then minus k plus 2 upon k plus 1 equal to 0 and 1 by 3 equal to 2k minus 3 upon k plus 1 is 1 by 2 and k plus 4 upon k plus 1 is 2. See, k must be same in these equations because here there is a unique k. K is not different for these 3 coordinates. K is a unique number. So it must be same. Now we are checking whether are we getting same value of k. If we don't get same value of k, that means k does not exist. K does not exist, that means this is not possible. In that case, points cannot be collinear. So let us find k. So this means minus k plus 2 is 0 and here cross multiplication 4k minus 6 equal to k plus 1 and here k plus 4 is 2k plus 2. Therefore here k is 2 and here 3k, 4k minus k, 3k is 7, so k is 7 by 2, and here k is 2. We have to check here calculation, maybe somewhere mistake. Say here points 2 minus 3 4 minus 1 2 1, kx2 plus ky2 plus y1 upon k plus 1. So this is 2k minus 3 upon k plus 1. It is 1 by, sorry, say here I have done mistake. This is 1 by 3. So this will be 6k minus 9. So this will be 5k equal to 10. So k is 2. And now look here. We are getting same value of k. So here, therefore, what is proved? We have proved that C divides line segment AB in ratio 2:1 internally. That means these points are collinear. So A dash B dash C, or we can say ABC are collinear. If we don't get these three values equal, that means division is not possible. And it happens only when points are non-collinear. So in that case, we state sentence that points are non-collinear. A point R with x coordinate 4 lies on the line segment joining points P and Q. See here, this is point P whose coordinates are 2 minus 3 4, and here point Q whose coordinates are 8 0 10. And P is R is a point whose x coordinate is 4. It lies on this line segment. We want coordinates of R. Suppose that its y coordinate is y and z coordinate is z. And we suppose that because R lies on this line segment, this point R divides in ratio k:1. Suppose that point R whose x coordinate is 4, y coordinate unknown, z coordinate unknown, this point divides line segment PQ in ratio k:1. Therefore, coordinates of R is equal to, always we keep coordinates of dividing point on left side, and by formula kx2 plus x1 upon k plus 1 comma ky2 plus y1 upon k plus 1 comma kz2 plus z1 upon k plus 1. So simplifying this, here 8k plus 2 upon k plus 1 is 4. So 4 is equal to 8k plus 2 upon k plus 1. This is equation 1. Here y is equal to minus 3 upon k plus 1. This is equation 2. Z equal to 10k plus 4 upon k plus 1. This is equation 3. So this formula will calculate coordinates y and z. And first equation calculates k. Now from equation 1, from this equation 4k plus 4 is 8k plus 2. So therefore 8k minus 4k is 4k. 4k is 4 minus 2 is 2. So k is 1 by 2. Putting k 1 by 2 in 2 and 3. Putting in 2 and 3. Y coordinate is minus 3 upon 1 by 2 plus 1 and z coordinate equal to 10 into 1 by 2 plus 4 upon 1 by 2 plus 1. So y is equal to minus 3 upon 3 by 2. Z is equal to 5 plus 4, 9 upon 3 by 2. So y is equal to minus 2 and z equal to 6. So therefore coordinates of point are x coordinate was given 4, y coordinate is minus 2, z coordinate is 6. Vertices of a parallelogram ABCD are given. Say here ABCD, it's a parallelogram. Coordinates of A are 3, minus 1, 2. Coordinates of B are 1, 2, minus 4. Coordinates of C are minus 1, 1, 2. And we suppose that coordinates of D are x, y, z. Suppose that coordinates of D are x, y, z. We want D. Now because this is a parallelogram, in a parallelogram diagonals bisect each other. These diagonals bisect each other. So midpoint of AC equal to midpoint of BD. Here this is a parallelogram. So diagonals bisect each other. Diagonals bisect each other. Therefore midpoint of AC is midpoint of BD. Midpoint of AC is equal to midpoint of BD. Now applying midpoint formula, midpoint of AC. So midpoint of AC is 3 minus 1 by 2 comma minus 1 plus 1 by 2 comma 2 plus 2 by 2 equal to x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. Midpoint formula equal to midpoint of BD. So midpoint of BD is x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. So midpoint of this line segment equal to midpoint of this line segment. So we are using here midpoint formula. So 3 minus 1 is 2. 2 by 2 is 1. This is 0. 4 by 2 is 2 equal to x plus 1 by 2, y plus 2 by 2, z minus 4 by 2. So this means x plus 1 is 2, comma y plus 2 is 0, comma z minus 4 is 2 into 2, 4. So therefore x is 1, y is minus 2, z is 8. So coordinates of D are 1, minus 2, 8. So this is fourth vertex. Now in this question, triangle PQR whose vertices are given. See here, P is 2a, 2, 6. Q is minus 4, 3b, minus 10. And R is 8, 14, 2c. Given that origin is the centroid, here origin is centroid 0, 0, 0. Origin is centroid. So using centroid formula, coordinates of centroid equal to coordinates of centroid of triangle is equal to x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3, comma z1 plus z2 plus z3 by 3. Simplifying this, 2a plus 4 by 3 is 0, comma 3b plus 16 by 3 is 0. Here 2c minus 4 by 3 is 0. 6 minus 10 minus 4. 14 plus 2, 16. 8 minus 4 is 4. So that is 2a plus 4 is 0. 3b plus 16 is 0. 2c minus 4 is 0. So a is minus 2. b is minus 16 by 3 and c is 2. So that is required values.